Donc, bonjour à tous. Donc, je me présente, je suis Olivier Joubert, je suis professeur.
Good afternoon. My name is Olivier Joubert. I work as a professor at the Nantes University. I also work as a chemistry in the electrolyzer and fuel cells. I'm also director of a department of the French National Center of Research, and we group some 30 labs working in the field of production, storage, and conversion of hydrogen through fuel cells. Well, I haven't come here to present my federation, but rather to moderate this roundtable. I'd like to thank the organizers of the conference first and foremost, and I will be in charge of giving the floor to the speakers who will be presenting the results of the workshops on scientific cooperation in the hydrogen field. These workshops took place yesterday, and they gathered Belgian, Luxembourg, German, and French scientists who showed to which extent it was important to exchange between scientists. And these 4 workshops dealt with several topics. The main purpose was to highlight current issues and actions that will need to be taken to overcome these obstacles and solve these issues after the afternoon. The rapporteurs and the chairs of the session are now here to present the findings of the workshops. So the rapporteurs will be introducing themselves throughout the afternoon, and each rapporteur, each speaker will have up to 7 minutes, between 5 and 7 minutes, to make their report, and we'll also have time for questions. First of all, I'd like to give the floor to Mrs. Hims. She's president of the Eurometropole of Strasbourg, and she will be telling us about the opportunities that arise in terms of overcoming obstacles. Now, let me start with the speaker on my left, and the workshop on scientific challenges to produce hydrogen. The workshop was chaired by Bianca, and the rapporteur is Aravind. So Aravind, you have the floor. Aravind.
Hello. Is this working? Yeah. The slides have to be presented, right? Yeah, just the press is green. Okay. So good afternoon. I will report from the session on scientific challenges in clean hydrogen production. And so I have the messages, I have the points taken from the session. So if you don't like the points, I'm only a messenger, so don't please shout at me. So and if you want to add something, you can always bring it in the discussions. Now, 3 main points coming out of this session. One is about low TRL research and industry connections. TRL means technology readiness levels. So 1 is usually low, and all of you know, 7, 8 probably high. So it's not a complaint that there is no connection between researchers and industry, but mostly researchers working on high TRL levels and industry are well connected through European initiatives. National programs probably helps better with connecting between TRL research and industry, but also Europe probably should look at such opportunities and initiatives and the need for such programs. Then the second point was about system level activities. So this includes building up new technologies, new systems by research groups, pilot demonstration mode, by industry, well connected with detailed system studies, like life cycle analysis, et cetera, that I will come to that. And the third one, the important point that we have discussed, was about the need for local hydrogen production. So in addition to the efforts to source hydrogen from Australia or from Africa, it's also necessary to look at, to produce hydrogen within European borders, but also even regionally, wherever possible. So to look at technologies for local production, especially in connection with those areas where it's possible, and try to build up the connections. So let me just get into the details. The first one will be about low TRL research and industry connections. So as I have explained, the main message is that it appears that industrial contacts are largely connected with high TRL research at universities and research institutes. So this needs to be changed. And especially if you look at, for example, materials and catalysts, et cetera, needed for future systems. And for one part, we all know that hydrogen is still considered to be a bit expensive. So if it has to, the cost to come down, and if the industry should remain competitive in the coming years and decades, then it's important that material research, catalysis research, et cetera, all need to be promoted, the basic research. And one, especially if you look at the time span we have, the time frame we have, it's very important that low TRL level researchers are also well connected with industry in material science or catalyst research or new measurement technologies, whatever. So that's industry interaction opportunities need to be significantly strengthened. So that's one of the key messages. And then how to do this? Well, joint research efforts at all TRL levels. So it's not about discouraging existing corporations at high TRL levels, but adding cooperation and joint efforts also at low TRL levels. And then, and in addition to that, low TRL research with European funding needs to be actively promoted. This is also a common opinion came out of the discussions. How? Networking events, maybe joint PhD candidates between universities and industry, industrial secondments, et cetera, all could be opportunities, or maybe there are also other ways to strengthen this. Now, system level activities. So in addition to that, because if you really look at 2030 as a target, we need to build up systems right now and connect it with detailed system studies so that whatever is achieved is well understood and it can be copied. I can also give a very simple example. What I am doing, for example, in Groningen, we have a megawatt scale test center to test electrolyzers, large-scale electrolyzers. And a PhD student of mine is already modeling these systems. And the learning points from this effort will be actually used for coming up with concepts for large-scale electrolyzers for the future. So we can actually build up systems, connect it with system studies, and use it for the future. And such studies need to be life cycle focused. Techno-economics needs to be understood so that these systems, if successful, could be copied in many places. Now, then if you do this at many places, it might be possible to come up with technology ranking, how to rank technologies for different applications and different conditions. Because maybe in one region, one technology is attractive, but maybe for a different region, it could be another technology. So ranking might be possible. And all this to be done with the full value chain focus. Now, some examples: nuclear hydrogen, biohydrogen with negative emissions. We had presentations today, renewable energy integration, geohydrogen, especially if you look at hydrogen to come just like natural gas to take out of Earth. And there are such initiatives, needs to be well studied. So these are all messages came out from the presentation. And if you look at local hydrogen production, again, technologies and systems for local hydrogen production to be supported. How? For example, there are different regions. North Sea in Netherlands, Groningen, well connected to North Sea, probably with wind energy and electrolysis. In France, farming is important. Biohydrogen from agro-waste might be an opportunity. Solar hydrogen production wherever possible. Maybe geohydrogen from Ukraine. So we had discussions about it. So that's all from my side. Thank you very much.
Thank you, Professor Aravind. Now, je voudrais laisser la parole donc à...
And I will now give the floor to our next rapporteur. And the title of the workshop was Supply and Logistics of Hydrogen. It was chaired by Michel Depape, and the rapporteur is Ms. Evrim Ursavas, who will be presenting the findings of the workshop.
Okay, so my name is Evrim, and I'm from the same university as Aravind, but a different faculty of Economics and Business. My research team focuses on the development of the new economic models and the business models much necessary in this energy transition. And our core expertise is on applied mathematics, data analytics, optimization, and the digital technologies such as artificial intelligence. Our research team also leads the HEAVEN program. HEAVEN is a place on Earth, and it's right in the North Netherlands, and the University of Groningen is at the core of it. And it's also the first hydrogen valley of Europe. And this is an open collaboration call for all the other hydrogen valleys that we hear, 23 of them, for cooperation and collaboration. Yesterday, we had a nice workshop on supplying and logistics of hydrogen. The participants came from different nations and sectors and expertise, which relates very well with the concept of supply chain. Because why? Supply chain encompasses the whole value chain, right? Right from the production, transport, storage, and end use. And here I took the liberty to copy a picture from our HEAVEN program, right, to show an example of a supply chain network design where we take the renewable energy from the North Sea, we bring it onshore, we produce the hydrogen, and then we distribute it to different end-use applications, such as for heating the homes, for use in the industry as feedstock, or for mobility applications, for example, for heavy truck or buses or taxis, or you can just be storing it underground in salt caverns. So this is the network that we are talking about, the value chain that we are talking about, and we believe having this in a good way, robust way, economic way is very important and shapes the future of the hydrogen economy. And that's what we are working on. During our session yesterday, we touched upon the different processes, for example, the production, where Aravind is the expert here. And okay, how are we need hydrogen, right? And we expect it to increase exponentially. Where are we going to supply it from? Is it going to be local production, or do we need to import it, right? Because, well, we need more and more, but we foresee the indications, and also if you look at the wind power roadmaps in the region, we foresee the supply bottlenecks, so we have to somehow be importing it from countries that are, well, can do it cheaper than us, but we have to look at the costs associated with it, not only the transportation costs, but the whole overall supply chain costs. It's not only the hydrogen that we need, but also we need to ensure that the supply of the electrolyzer components are there. For example, for the different type of electrolyzers, like PEM electrolyzers, the raw materials are scarce. So how are we going to ensure that we don't have a bottleneck over there? Once you have the hydrogen, then you need to, of course, distribute it, right? And to do so, you can use different modes. We focused mainly on the EU hydrogen backbone, which we need. This is the chicken and egg problem, right? But if you don't have the infrastructure there, then you cannot have the demands. So this is important, and it's important to start it at the regional level and extend it to the other regions. Backbone is important, right? But we do need to consider the timeline that is necessary for it, for not just for the infrastructure, but also the regulations and so on and so forth. So it could be that at some places we will be having our local energy system. So the question is centralized, is it centralized or decentralized systems, and to what extent? Thereafter, well, you can be distributing, what are you going to distribute, right? You can be having the hydrogen in different forms. You can liquefy it, you can, well, combine it with different carriers. What are the possible options? We foresee that we would need to have different molecules for different end uses. We also talked a little bit about the blending of hydrogen, but mostly the challenges associated with it. For example, the increased difficulty with the emission calculations in the ETS allowances when you have mixed molecules. We also talked about the demand side, the drivers, well, the expected drivers, the currently using industry that use the hydrogens that is currently in gray. It could be the main uptakers, the transportation sector with the heavy duty vehicles, and thereafter we see a diverse use as, for example, in the aviation or the biofuels. And one of the most important drivers we foresee is the forming of the clusters and hubs, hydrogen valleys. Why? Because we have the different applications brought together, and these provide us the much needed economies of scale. Of course, the certificates of origin are very important if we want to be importing or if we're thinking of cross-border collaborations. Safety and social acceptance is one important thing. In Hoogeveen, we are now using the hydrogen to heat the homes, but if one household says no, the project stops, so we know how important that is. And one participant talked of using different outlets such as social media and YouTubers we can get help from. Then I want to conclude with the overarching principles. We have to see the dynamic nature of this transition. We're talking about a roadmap, and at different points of time we will need, well, these different infrastructure needs. When do we need what break-even prices? What type of investments need to be realized at which time period and what amount? And I think the main takeaway from our session was the complexity, right? We're dealing with multiple stakeholders. We're dealing with uncertainty in demand, in supply. What are we going to do with this? How are we going to manage this? And I think there, the use of technology, the digital technology, use of optimization tools, mathematics, and base our decisions on facts can be important. Well, thank you.
Thank you, Evrim. L'atelier, donc.
So the third workshop that took place yesterday was about different types of usage. It was chaired by Nicolas, and the reporter is Patrick Hendrick. And I thank him in advance. We do have a small issue with the remote control, apparently. So, Patrick, while we are sorting this out, can you maybe introduce yourself and try to stick to the timing, which was 5 minutes? Sure.
It's Patrick Hendrick. I'm professor at University of Brussels, ULB, the French-speaking one. And I'm involved in different research projects related to hydrogen. One of them is BEI, for which you had the poster outside during the poster session. And also I'm in another one together with Aravind, funded by the Clean Hydrogen Partnership that is called TCHI. So on something that we have heard a lot this morning and yesterday related to education and training related to hydrogen. So yesterday during the session that was chaired by Nicolas Keromès from University de Lorraine, with 18 participants in total, we discussed mainly 4 topics. So the first one was related to transportation, especially public transportation, but everything related to transport sector. Another one that has been apparently also discussed in the working group 1 was the local generation of green hydrogen in and around buildings. So you can have it around, but you can have it also inside the building, stored in the building. And a third point was related to hydrogen cogeneration boilers and heating networks. And the final one for the applications was related with hydrogen in industry. and certainly the problem of cross-sector coupling that has not been really a lot mentioned until now in the different sessions. I don't have any more the remote. Okay. So the topic 1, transportation related to low emission, and this is of course a problem, is a lot dictated by the low emission zones that have been distributed and decided a bit everywhere in the cities in Europe. So certainly we have to use hydrogen in different applications, especially heavy ones. So they are dictated by speed, of course. Everything is related to speed square, the mass and the autonomy. So the length of the mission, the number of hours and the number of kilometers that are done. So you have there, of course, buses, coaches, so very long distance buses, heavy trucks, utilities, small vans, taxis. For cars, we can have certainly some restrictions, but we discussed there also the fact that today, really hybrid BEV, so battery electric and hydrogen electric vehicles are not really existing on the market. There is no product that is really available. They will be pretty soon, but this is certainly a place where you need to work. We need to work a lot in development. Of course, the obstacle for transportation is the price of the vehicle. Today, it's extremely expensive, and the price of the hydrogen. We certainly insisted on the fact that auto sharing, which is today for hydrogen cars, not really available on the market. There is no, let's say, company offering that for auto sharing. Would be a very attractive solution, especially for the weekend, of course, long rides that you need to do. And of course, in a lot of countries, the infrastructure, the refilling infrastructure is quite poor. If you take Belgium, for example, in Brussels, we don't have one. So we have 0 hydrogen refilling station. They are outside of the city, but none in the city. And it's like this in a lot of countries. Of course, there are countries where it's much better, like Germany, but it's not the case in all European countries. We discussed also about regulation, certainly to be harmonized between the different countries in Europe and also the non-EU countries like Switzerland that is represented here, the ETS influence, and even the problem of H2 fuel cells versus H2 internal combustion engines. Of course, internal combustion engines are much less efficient, but they are available, and European industry is extremely strong in this field. So this is certainly still maybe to be considered. Topic 2, so hydrogen generation in and around buildings, especially related to near zero energy buildings. So seasonal energy with fuel cells, energy and heat storage. This is the clear, let's say, gain that we can have with hydrogen. Of course, to use it only where it will be really needed, so where there is no solution using heat pumps, for example, because the cost, especially the capex, are extremely high. This is leading to most probably interesting and future solutions that are collective solutions, like smart districts in cities, and also to make revenues that are maybe not really existing today, using digitalization and aggregators. They can bring certainly solutions in order to bring revenues, and so let's say go against the high capex cost that you have. So cities are seen certainly as a place where hydrogen generation around buildings could be a clear winner. Topic 3 was related, it's linked with the topic 2, cogeneration, CHP boilers, and heating networks, again related to seasonal energy storage. The cities are extremely hard to decarbonize. The gas distribution network is not at all adequate to transport 100% of hydrogen. And so we discussed smart districts, 200, 300 houses with a central storage, maybe outside of the district, with one cogeneration unit and a heating network for whole houses. And certainly there, we need demo projects. They need to be started soon so that cities, authorities, they need to decide to select a district where they have to implement something like that at a broad scale in Europe in different countries. Yesterday, we also mentioned that there is no fear against H2. The citizens are certainly not the obstacle for that. We need to convince the administrations, maybe with the permitting and so on. Wind is certainly also greener than PV. So PV can be interesting, but wind is much less CO2 producer than PV for local hydrogen production. And the fourth one was the use of clean hydrogen in industry. Of course, seasonal energy storage, the same. Import, a big question mark. First for the feedstock, for the fertilizers, for example, the fuel treatment from the biomass, methanol, where you have 4 times H. That's why I've put the formula here. And of course, as an energy source in a second place. There, the problem is clearly we need low cost for this low CO2, this clean hydrogen or this clean ammonia that we would have to use in the industry for the competitiveness of the industry. And clearly we need to see that if you speak about industry, cross-sector coupling with hydrogen must be much, much, much larger than anything else in the past. So we have almost no sector coupling today. With hydrogen, we will need to make it existing, and we need to work on that. And for industry, we started like this yesterday. It was the first point discussed, permitting procedures. So it needs to be easy for industry. Today, permitting procedures are not easy enough. They are too complex. They are different from one country to another. I have a company, I don't know which one, is making the work in France. They do not need to restart the work in Germany and to restart the work in the Netherlands. The permitting procedures must be almost identical everywhere. So this is what we have discussed yesterday. I'm available if you have questions.
Merci, merci Patrick.
Thank you very much, Patrick. So after the 3 workshops about production, logistics, and use, we have one last workshop that was chaired by Thomas Jordan. The reporter is Laurent Anthony, and it was about hydrogen and society. Hi, Laurent. Hi, Olivier. Hello, and hello, everyone. I'm here as the chair of Hydrogen Europe Research, which is the European Association for Research. We have 108 members coming from 20 member states and 25 countries, in fact, in all. So we're a European research community, and we'd be very happy to talk about the first point that was mentioned before with Aravind. So the 4th workshop, which was chaired by Thomas Jordan and Carol Smith, we had about 20 participants, and we talked about 3 main things. So when we speak of hydrogen and society, I mean, very quickly you have to think about social acceptance. And then very quickly, when you speak of hydrogen, you also speak of safety. And then finally, and Patrick mentioned it, there are some regulatory aspects as well. We want to set things up, but we also have to deal with standardization, regulation, and all those aspects. So for social acceptance, I mean, we have covered quite a lot of questions. In terms of communication, what is the perception by the people around us and by ourselves, not experts, but the general public? What is the perception within the population of hydrogen as a whole? Are we communicating the right information at the right level? And do users, present and future, are they convinced that using hydrogen will make it possible to contribute to the fight against climate change? So, this is, I mean, what we discussed in terms of communication was that we really need to harmonize and synchronize communication about hydrogen. We tend to be too technical and too complicated too soon, and very, very, very quickly the broader audiences feel lost. We are speaking about words and colors that don't always have or concepts that don't always have the same definitions, and that can be disruptive as well. Very quickly they feel like they don't understand anything. So as a community, we must coordinate ourselves, use the same words to explain what hydrogen is, what hydrogen's advantages are for the environment, for the economy, and also for just the common good and the good of each and every one of those who use it. The second aspect, as I said, has to do with safety. From that perspective, we also must be a lot more accessible and user-friendly. We must communicate concretely about the level of safety of hydrogen technology. There's an image that I use very often, and that is when you speak of safety, when you show a hydrogen vehicle used by firefighters, that already, I mean, it's one image worth a thousand words, right? So using that for communication, such a simple but visually striking element, can be very useful. Finally, and we have talked about it already, regarding our collaboration with the different regions, we always have, from a communication perspective, I think it's necessary to make sure that we talk about hydrogen at a regional level. Nothing is better than to work with the regional press, regional, local journals. Those are read by so many people, and not just people who are city dwellers or who live in capital cities. If you work with regional press, then you can also show where we are in terms of deployment, technological maturity, and we can also insist on what is happening locally in terms of industries and on a more local level. So those are the more concrete goals. And the word acceptance, social acceptance in and of itself, we said is not really appropriate. When we speak of acceptance, some people feel like we're trying to force something down their throats, when in fact we should make them want to use such a technology or make them trust that technology rather than speaking of acceptance. Another point has to do with safety again. So we're all convinced, we all know that we cannot, safety is no joke. And there can be no compromising with safety. So when you want to develop a proof of concept, a demonstrator, what are the main difficulties of the project bearers? And what came from the group was that, in fact, and we heard it before as well, the main issue has to do with the permits and authorization. So that can be a problem when trying to set up a project. But I'm not here to criticize public authorities. We rather need to help them. So we need to work hand in hand with them at a very close level to provide information, answer questions, sometimes even ahead of projects, and really work in a collaborative manner on the day-to-day between public authorities and project bearers, so throughout the value chain. And in terms of safety as well, if you want to create bonds and links between regions and Europe, we have at EU level a committee called the European Hydrogen Safety Panel, which exists. We have about 15 European experts that are dealing with safety aspects of hydrogen and being able to build bridges between regional stakeholders, whether they be public or industrial, with that European expert panel. That will make it possible for us to support those people, give them training, exchange in terms of expertise, guarantee a better use and guarantee that recommendations will be followed. Also that we can gather information if there are incidents, so that we may have concrete elements to convince public authorities that the technologies that we develop are safe. And then finally, and we spoke about it before as well, we need to harmonize the safety constraints. We need to standardize the constraints. When we're dealing with safety concerns in one country, sometimes you have to start again from scratch because you work in the next door country. So we need to harmonize things, and we need to have a possibility to interpret the law in the same way, because sometimes the interpretation of some laws are not entirely understood in the same way. So we thought about ATEX, for example, and the way that the regulation is understood can modify the safety aspects. Finally, from a regulatory perspective, we're all convinced as well that we have to set up a regulation, but that regulation needs to be the right regulation, needs to be standardized. We said it was important this morning, and standardized in the right way. The idea is not to standardize for the sake of standardizing. It has to be as efficient as possible, and it cannot happen too early in the industrial development so as to give people a little bit of, leeway. One of the obstacles is when you're developing a project or a product, you need to guarantee interoperability at European level, whether it be refueling stations, vehicles. There are some countries where things work, others where it doesn't. You need to have recharging protocols or reloading, refueling protocols that are consistent so that I know that I can drive from one country to the next. Electrolyzers were mentioned this morning. If I make an electrolyzer, one operator that can use electrolyzers coming from different suppliers. I mean, for that to happen, you need to be able to communicate with all of those electrolyzers. And we also must try to avoid setting up too many constraints from a hydrogen perspective, constraints that will be made worse at local, national or regional levels. Sometimes you have extra layers of regulations that apply at a local level. Another aspect that we thought was important is to guarantee technological neutrality. Too often, we make a difference between battery vehicles and hydrogen vehicles. We should talk about EV vehicles, electric vehicles. So we need to promote that technological neutrality. And finally, if we really want to defend hydrogen in order to achieve our climate change goals, we mentioned it yesterday, well then we must make sure that users can trust the technology. They must be convinced that using clean, low carbon hydrogen has an added value for the environment, is beneficial for the environment. So we said carbon footprint matters, but we must make sure that for all energy vectors, we should have that holistic life cycle analysis approach. It was mentioned this morning as well. It is not the case yet, but in the future, in order to guarantee transparency, we will have to have this approach of a holistic life cycle analysis. The last point has to do with regulation. Today, when you want to invest, you notice that regulation-wise, at a European national level, it is a headache. So hydrogen is mentioned in a lot of different regulatory texts. If you want to develop a hydrogen ecosystem, you have to be a lawyer first if you want to get anywhere today. So at a political level, rather than putting hydrogen everywhere, we say we need to do it the other way around. We could have a small family of laws about hydrogen as a vector with different applications, but it's important for the end user or for the user to have a limited number of law texts that they can read to know exactly what they can and cannot do, and that will give confidence to industrialists, give confidence to investors as well, because they will know that the regulation is in place, it is clear, and it is sustainable and perennial. So that's the results of my workshop. Thank you, Laurent. I would just like to thank you all very much. It was a lot of work, I know, for you to be reporters. I'm quite sure that you worked last night and this morning, maybe even during the lunch break. So I think you have covered in very interesting presentations all of the obstacles that may be scientific, or technological in nature. You can have some obstacles that are cultural as well, or regulatory obstacles as well. And I think that to the back of that, there are a lot of actions that we can do. And I will leave the floor to Pia Ims, who will conclude this session. I thank you very much for taking the floor now for our small conclusion. Yes, thank you very much, and hello again. I have given an introduction for today this morning, so I'm just greeting you again. I would like to thank all the political, economic and university personalities that we have in the room right now, and I'd like to remind you of the overall overarching goals that unite us today. Our overarching goal is carbon neutrality by 2050. We're all concerned by the Paris Agreement to limit the overall temperature increase to 1.5 degrees. And we know and we want for Europe to accelerate the energy transition, especially in the area of transportation and mobility. So where the development of hydrogen can become or can play a central role. This is what we are talking about today and yesterday. The workshops have shown that reinforcing scientific, technical and economic cooperation is key. I would like to insist more specifically on what's just been said about the infrastructural issues. We have seen, and who has said throughout the morning, we have seen that regulations can be quite a burden and can be poorly coordinated as well. Harmonizing things at a European level is key, and we also must promote the cross-border character of our approach in general. We have seen that it was necessary to simplify everything for industries, and it was important also to have some proofs of concept to welcome and embrace a consensus around a technology that can yet, I mean, for the moment, still raise some concerns. It's also important to share political roadmaps at every levels of decision-making, whether it be regional, national, or European level. It's important for us to achieve our ambition in terms of carbon neutrality. If we want for that to become reality, we will have to do that. Let me tell you a few words about Strasbourg. We're fully committed to this dynamic. It is also part of the national low carbon strategy. We do have a climate plan for 2030, and we're working very hard on decarboning the ecosystem, especially from a mobility perspective. We are going to have more trams, tramways. We are going to double the railroad offer at the scale of our metropole. We've been working especially with the Grand Est region. It's also important for public powers. I mean, what we do. It's important for us to subsidize the purchase of clean vehicles. And in our city we also have a low emission area, so it's very important, and we want to move towards decarboning. We have the ZFE, of course, that will the low emission zone, the low emission area. That makes it necessary for us to communicate with our inhabitants to change our modes of transportation. It's important for us to provide support to companies through a climate agency, and companies do want to benefit from EMRs, and within that framework, hydrogen plays a big role. The Eurométropole of Strasbourg is engaged into a carbon neutrality strategy for 2050. For all big cities, it goes through sobriety, energy efficiency, local production of renewable energy, and more specifically, we want to fight for a better air quality, less air pollution, and we want to fight so that fossil fuel, which are quite a burden for the purchasing power of households and companies, we want to make sure that we can find new answers and alternatives, especially or including through hydrogen. We must, all of us, work hand in hand on acceptability, on acceptance. We must indeed awaken trust in this energy, and we must make it more available. From an operational perspective, this ambitious strategy goes through a roadmap of decarbonized mobilities. As I was saying, the questions of infrastructure, production, and supply are key to that. We have been working on changing the life basin around Strasbourg, and we have that model of the Upper Rhine living basin, and I'm very, very happy that we could collaborate with researchers, with industrialists, to go together towards that same goal at that geographical scale. Within that context, green hydrogen occupies a very important position. It can help us decarbon some of the key sectors like the industry and mobility. I wanted to highlight how much the metropolis has been supporting very innovative projects like Irène, which is supported by RGDS. It's a project that is ongoing, the idea being to produce carbon neutral green hydrogen based on local biomass. We have talked about it this morning as per the patented process of thermolysis. So that's the chemical decomposition caused by heat that makes it possible for us to use methanization as a process as well. Beyond supporting those innovative projects, Strasbourg, because of their status as a European capital, would like to work within the European corridors where we know that different themes are discussed. We have an autonomous port in Strasbourg where we are already working on port ecosystems and hydrogen, coordinated by France Hydrogène, in order to have a look at what potential hydrogen has for the port areas. And there again, we broach the question of logistics, which is very important for any and all big cities. The law about climate and resilience in France will lead us to exit diesel, and we will again have to implement low emissions area. So we're a member of the Region Grand Est club, which is created around the consortium called thematic, which is very visible today. The idea being to give an impulsion and to accelerate the development of our sector throughout the value chain. We said it, the whole value chain needs to be questioned from production to users, and we must place hydrogen at the heart of our energy transition in general. A lot of challenges remain to be taken up. I know that from a political perspective, the expectations are quite high. We need to make regulations less of a burden, coordinate better, go faster. So the value chain must improve as well from a logistics perspective to make life easier for companies and people. And we also must work with the ADEME. The ADEME has launched a call for project called Hydrogen Territorial Ecosystems. So we have 275 million euros for 2021 to 2023. We will need to seize that opportunity. Grand Est is supporting the conversion of fleets towards low emission motor solutions, and we must really take up those potential financial supports and sources of support to develop development and massification within a very short period of time, because we are in a climate emergency. We will need to support and reinforce the maturity of our field. We must make our investments more resilient. We must achieve economies of scale, and we must make sure that green hydrogen is a real energy vector to answer this emergency. We must act quickly. We must act in a strong way. The Eurométropole of Strasbourg is committed to doing so, and I would like to wish you all courage and tenacity, especially to researchers and industrialists in the room. And again, it's important for public powers to mobilize at a regional, national and European scale in order to facilitate this transition, which is so important for us and that is so key to our future. Thank you very much.
Merci à tous, et on va passer certainement au
Thank you very much. We will now be moving to the next roundtable. Thank you very much for your summaries, and thank you, Mrs. Ims, for your conclusion.